cloud. Okay, so it has started recording. Okay, so once again, the meeting recording has started and you are still here, indicating that you're consenting to be recorded. So good evening and good afternoon, good morning, depending on where you are. And I hope you had a wonderful Thursday, or and maybe at least one of you is already started to enjoy their Friday. Okay, so welcome to our third Zoom session. And before we get into our agenda, just some etiquettes here. Please do not start or use your video unless necessary. Please mute your microphone when you're not talking. Limit any distractions around you. And for any questions, comments, please wait until I open up for Q&A. Alternatively, you may also send your questions or comments to me or to Yelena in the chat room, but we'll try to monitor that as frequently as we can. But, please feel free to speak up, guys, okay? Unmute yourself and speak up. I will absolutely, you do not hesitate to do that. Webinars, this kind of Zoom sessions will be typically an hour or less. And so again, my goal would be to get you out, within an hour's time today and not any longer than that. Okay, so let's see if we can keep up with that. And, please mark your calendar whenever you get a Zoom invite by email. So I hope you all are coming here by, with the virtue of getting an email from me a couple of days back. If not, there's also an announcement in the classroom. So if you're not seeing that email, please let me know offline, and I make sure that you're included in that email whenever it is going out for the future sessions. Okay, so with that, our agenda for today, we will kind of talk about our main, the module is based on data preparation. So our main topic is going to be data preparation. We'll talk about data preparation. We will talk about assignment 2, and then we will get into your questions. Okay, there were a couple that got recorded in the online questions.org website, and there could be a few here, or anything impromptu that you have. We will certainly take that up. Okay, so with that, I would, as I'd always like to start with some humor, just to put a smile on your face. So I'll give you a few seconds to read this about data. Okay, I hope this has put some smile on your face, and a good way to begin this session. All right, so before we kind of get deeper into our discussion on data preparation, just wanted to share some important quotes from people who were engaged or involved with data at some point in time. And there's some wonderful quotes here. So the first one comes from Mike Smoker. Things get done only if the data we gather can inform and inspire those in a position to make a difference. So Mike was, a school teacher, a coach, and later went on to doing a lot with data. And I love this quote. I think it's very powerful, right? So that's my number one there. The other quote that I really liked about data is this one from Carly Fiorina, who was she was the former CEO of HP. The goal is to turn data into information and information into insight. Okay, nice. The next one is from Dr. Kurt Blacker. Data that is loved tends to survive. So again, yes, absolutely. And Dr. Kurt is one of the technologists, very well-known technologist. And if you look up these guys, you would know, they have been in the field for quite some time. They've been technologists, they've been data scientists, doing a lot in their career. And the last one here, if somebody tortures the data enough, open or not, it will confess anything. It's again from another technologist from Italy, Paolo Magrassi. So yeah, some wonderful notes about quotes about data preparation, just kind of hinting at why data is so important, and managing data, transforming data to gather the insights and analysis and some intelligence from it is so important for any organization that you'll be working for or represent. So yes, just a proof of that, right? I mean, just kind of taking in a snapshot from, about, there was some survey done with, survey with some of the organizations. And in that survey, so many of the organizations, like 65% of the organizations said, it is very important to simplify making information available. The most often required big data preparation activities are ensuring quality of data, then extracting data from sources, establishing security, that's 61%, 63% from extracting data, 68% ensuring quality of data, and 51% accessing data for integration. So as you can see, hands down, ensuring quality of data is the winner here with 68% of the organization think these are the most often required big data preparation activities. And in the analytic process, the tasks in which organizations spend the most time are reviewing data for quality and consistency. 52% of the organizations think that. And preparing data for analysis, 46% of organizations supported that. So now you know why this is the first thing we are talking about here, right? Right after problem framing, what comes, and when you have the data on hand, you don't just start building models with it, right? You start thinking about, is the right data in the right shape, form that I really need, and that it will lead to a quality modeling, statistical modeling, a quality decision making, right? So what are the different types of data? And this is something that you may have gone through in your reading. The two types of data, right? So categorical data and a numerical data. And I don't think this needs any further explanation what these two mean, right? Categorical is more of, kind of a string kind of a data, your text kind of a data, and numerical is the numbers kind of data. Now, once again, categorical are two types, one being nominal, where the ordering, there's no any kind of a rank order for that. It's just free form text, you could say. Ordinal is where you have some kind of a rank ordering, like Sunday, Monday, Tuesday, or small or medium or large and extra large. These are kind of an ordinal kind of categories, ordinal kind of text information. In the numerical, you have, again, it's divided into two. You have interval data, where the difference between the values, like for example, calendar dates, right? You have the interval data, and that's where difference of value is meaningful. And you have ratio type of numerical data, where not just the differences values is important, but is meaningful, but its ratio is also meaningful, right? You can think about distance, you can think about temperature, you can think about all that, where the ratios of these would be equally meaningful, right? As much as their difference. Okay. So now, as you all know, the data in the real world is not usually analysis ready. And yeah, this I don't know, I hope this has not come as a shocker to many of you, especially who are already in the workforce and been working and seeing different kinds of data, or even, you've been in academia or you've been around and been working with lots of data sets before. This should not come as a surprise or a shock at all, that most of it is, you don't get to work with an excellent or a beautiful, clean data. It is many a times, it is, you would find missing values in it, it is incomplete. It would contain errors, which you call sometimes even call noise. It will have outliers. You all talked about outliers, right? I'm sure you done have lots and lots of research, and we'll get into that a bit here today as well. But yeah, that's the other thing that you would find in your data. You'd find a lot of inconsistencies, discrepancies, right? Where, let's for as simple as a gender column may have somewhere it would have an M or F. In some places there would be male and female. Some places the M would be capitalized and not capitalized, so on. I mean, you could just, it's sky's the limit when you think about all the different discrepancies your data can have. And when you have such kind of a data and, such kind of an inadequate quality data, and if you do not do anything about it, what happens? It definitely leads to inaccurate statistical analysis or modeling. And simple as garbage in, garbage out, right? You throw in a garbage to your model, that's what your model is going to give you back. The analysis that it's going to give you back is garbage. You're not going to be able to make quality decision making. And that's what makes data preparation so very important, right? And there are techniques, and it's not the end of the world. When you look at the data and you say, oh my God, there's so much to do. What do? Just throw the data away? Maybe not, right? When you have missing values, well, there are techniques. You can take care of missing values, and missing values doesn't need any more description, right? It's empty. The fields there's no value provided. It's empty. And many a times, you simply know what to fill it in, or maybe there are techniques where you would fill it with certain, mathematical, values like a mean or a median or average or a mode. You try to kind of fill with that, whatever makes sense to your data set. So, but anyway, it doesn't need a lot of, discussion about, because you know what missing values are. So what we can discuss a little more is about the outliers, right? So what are outliers? Again, I'll not go into too much details because I know you guys have done a lot of research, a lot of discussion around it. So I'm not going to spend your time or make this hour, really boring for you by going over and explaining what outliers are. But in general, right, if you're just going to be talking a little bit about outliers, then we all know it's something that is, these are like considerably different, than the remainder of the data. Anything that deviates from the other observations. And, and then you start thinking, hey, is this the right data set, or is this the right data? Is there something wrong about it? Was this not input correctly? Was this not recorded correctly? And time and again, one of the easiest things that you could do or think about doing is, hey, should I just remove them? This data set is not, in the area, right? It's not, within the other, it's not with the rest of the data. It's not in the alley. It's not on my driveway. It's not in my house. Just throw it away, right? It's very natural to think about that, especially when you have a huge data set, when you have millions of records and you find that, hey, you've got 70, 80,000 records that are all your outliers. Well, your first instinct would be just throw it all. But before we kind of make that judgment or make that decision of removing them, right? Let's table this for a while and think about all the reasons why outliers exist in the data set, right? So why don't we use our own tool that we just learned last time, the last module, the RCA tool, right? The root cause analysis tool. And let's go from left to right, right? So where outliers form, again, there are types of, like, these are caused by data errors, often caused by humans, right? It can be caused by machines as well, but the chances are that maybe it's, some of the human error, there are some human errors there, some data errors being made. Somewhere it could be misreporting. We saw that there were so many birth dates in the example that in the discussion, you saw that many of the birth dates are 1969. And many of you pointed out, maybe that's misreporting. Maybe there are a lot of people who are not reporting the data correctly. And that's why we have, we have this issue about it. There could be a sampling error. Data could be coming from multiple sources or samples. Maybe those samples that you used have got errors in them. Very similarly, there could be different data sources, not just different samples that you're picking up, but there could be different data sources. You could be, one data could be coming in from one agency and the other could be coming from another agency, or one organization or the other organization. And you'd be surprised, and how many times you would see a data within the same company, but different organizations store it in different ways. As simple as even an employee data, which is stored in one organization, could be so different. And it becomes a nightmare to merge these data. Just as simple as the way they would have captured certain information about an employee. And once again, I'm not making this up, but once if you are in the workforce, or when you go into the workforce and start working with organizations and with data, you'll realize that this is a reality. And that's why we kind of are talking about this so much, right? Because this is the reality, and this is what we'll need to do on each of these scenarios or situations. Then there could be a change in process, right? Maybe a year back, you did not have all the tools and the wherewithal to kind of capture your data correctly, but maybe you have it now. Maybe you had it yesterday, but do not have it now, right? Some of you said, okay, maybe we should capture through your license IDs or driving licenses, and maybe have that kind of IDs to capture this kind of data. Okay, fine. Maybe then at some point you drop that and you said, oh, okay, no longer will be using license. So all of a sudden your process changed. So there could be some errors due to that. Now going forward, maybe your capturing of data would be kind of little faulty. Then there's also another reason, which is the purpose of study, right? Where your study could be actually finding out this fault and anomalies. Now, not all anomalies are bad, right? And the reason I say this, if you are especially in cybersecurity field, right, or in kind of any kind of security, your anomalies are so important. There could be thousands of logins into your application, which are all good. These are all good data coming from all your valid users. Now, all of a sudden, there comes a user who's trying to get into the system with some weird or multiple passwords attempts. What is that, right? It's an anomaly. You want to catch that, right? Somebody's there trying to access your system. Somebody's trying to hack your system. There are some queries being sent out through the network into your system, which are going to be harmful to your system, right? These are like the faults and anomalies. And that's why there was such a huge discussion we had on outliers, because yes, there could be some good, you could be actually, working to find or detect these anomalies and really work with them and not make them throw away. And that's the reason why we are having this discussion, because yes, it's a very, very important, especially as I said, cybersecurity field, you will be talking about anomalies much more, right? So now, how do you identify these outliers, right? There are multiple ways. Talking about box plots, there are scatter plots, the histograms, the easiest ways, right? Because as they say, when you have a visual or a picture in front of you that says 1,000 words, it's so easy to detect anything very quickly. Instead of looking at thousands of rows, that's, you'll have to really scan through thousands of rows to really find out which one is anomaly and which one is not, right? And then there are other ways, mathematical ways as well, where you can use mean and standard deviation and interquartile range. And then we'll kind of talk about that a little bit. But let's see what a box plot is, right? And I know some of you already went into, looking into the box plots and talking about the box plot, which is nice. Actually, box plot is one of the most popular ways to detect an outlier for your numerical columns. where, and let me quickly explain to you what a box plot is. So this is also called a box and whisker, these are also called box and whiskers and box and whisker plots. And what this is showing here, this entire box and whisker is going to capture the range of the data within that column, right? Whichever that data that you have in hand, it is covering the entire range. Your minimum value is going to be the bottom of the box plot. This is your minimum value in that particular column. And then the maximum value is the topmost value here, right? Now, the whisker from this point to the bottom of the box is going to cover the 25% of the values. And that's why this area, this lower portion is called the 25th percentile, or called the first quartile, or it is also called as Q1. The next 25% are within the bottom of this box and the middle of this box. So that's the other 25th percentile. And this is this middle line here. This is the median. This is the 50% of the records. So 50% of the records are from this line to the bottom of this box and whisker plot here, right? That's your 50%. And the other 50% are from this middle line to the top of this box here, right? So this is the 75th percentile, and this is 50 to 75. This is called the third quartile or the third quarter. And this is the fourth quarter, which is this another, once again, this whisker here. Now, the way to detect outliers, you could say, okay, anywhere, where if you have any outliers, if there are some very large or very small values, they may be just like little dots here outside of this. But how would you still, do this little scientifically, the little mathematically? So what you do is you draw a kind of an imaginary fence here at the bottom and at the top. And the way you come up with this fence, where would you draw this fence? You would draw it which is equal to, going to be equal to 1.5 times the interquartile range. What is interquartile range? The difference in value between Q3 and Q1. This is your interquartile range, right? So take this box right at the bottom, multiplied by 1.5 times, you will reach this point here, which is called the lower fence. Same thing here. You go 1.5 times from the top of this box, and you go 1.5 times here, you will see the upper fence. Now, anything above this fence and below this lower fence is what your true, outliers are. Now, once again, we are not come to conclusion yet, or we are not deciding yet whether they need to be removed or not. It depends on the data set, right? But this is one way of looking at your data and making sense out of it, whether it has outliers or not, right? Then, so this is one popular method. The other method is looking at this in a scatter plot, where you have, let's say in this case, you have a student weight in kg in the x-axis, and you have a backpack weight and y-axis. But once again, what is important here that I'm trying to show here is that your outliers are so easy to detect, because you see all your points here, but these 2 points are not within the range here, right? So once again, very easy to identify through scatter plots. The next is the histograms. Once again, very easy to identify. You see all your bars here on this side, and there's one outlier, right, which is far away from these boxes, right? So again, it's easy tool. These are some of the very simple tools and visuals that can help you to identify your outliers. Okay, so any questions on so far, whatever we've covered? I hope everybody's with me so far. Okay. All right. So The other way to identify is, when you how would you identify an outlier, right? Like it is using the mean and deviation, standard deviation, mean and mode and median and standard deviation is through this method. Let's take an example here, right? Let's say you have 12 numbers here, all listed in this order here. So these are each of the numbers here. Now, if you do the math, your average or the mean is 2.58. So these are the set of 12 numbers. You add these numbers up, divide by 12, you get 2.58. Your median is 2.5, which is the, how do you find the median? There are 12, when the numbers are even, you do n plus 1 by 2, which is, in this case, it's 6.5. So it is between 6 and 7. So you do the average of these two, then you get 2.5, right? You add these two numbers, divide by 2, you get a 2.5. Mode is the number that occurs the most in this data set. So, and that's what is the number 2 here. So this is the formula for standard deviation, which is the measure of the amount of variation within this data set. So the way you count it is you first find out the sum of the squares of each of these numbers. So you do the square of each of these numbers and you sum them up, it will be 93. Then you do a square of some of the numbers. So you sum all these numbers up, which comes to 31. You square that, that's 961. And you know that there are 12 numbers. So now this is the formula for standard deviation. You do the math, your number comes out to be 1.08. Now, what this means is the lower the standard deviation you have, the numbers are much closer, right? Your range of your numbers in the data set are much closer. If this was higher, your range, your numbers would have been distant apart, right? So anyway, so that's about the standard deviation. Now, what you do is anything like, this is classify your data points whose distance from mean is beyond 3 standard deviation. So what that means is, like, let's take any point, right? And xi minus mean greater than 3 times standard deviation is what you want to check. So for example, on the previous slide, if you take number 4, if you take the absolute 4 minus mean, right? And the absolute of that and greater than, is that greater than 3 multiplied by standard deviation? So is 1.42 greater than 3.24? No, then it is not an outlier. Same thing you try with number 1. You do the math again, you come out and you have to just check, is 0.42 greater than 3.24? No, it's not an outlier. Now, to this data set, let's check if number 10, if this number 10 is thrown into this data set, would that become an outlier? Yes, if you do the math, you get that in the right-hand side, 7.42 is greater than 3.24. So yes, it will become an outlier, right? So this is a mathematical way of, finding out the outliers. So you have, you can either do it visually or you could do it this way to find out, what's your outliers. Now, there are multiple ways to fix outliers. You could, some way to, you could just remove these outliers, right? As some of you already mentioned in the discussions, right? Let's remove them. Well, that could be one of the things. Or you could just eliminate the observations at both the extreme ends. So anything that you think is beyond the bounds, right? Out the upper boundary and the lower boundary, you come up with those boundaries and you remove the numbers at both the extreme ends. You could also normalize the data, right? You could transform the data and you can normalize them so that your data is always going to be between 0 and 1 most of the times. That way you can normalize it. And then you could replace with probable maximum. Like if it is, in this case, If this is going up from beyond 100, if there's any number beyond 100, you would mark them to be 100, right? So the multiple techniques that you can apply, you can come up with your own based on your knowledge about the data set, right? But just showing you some of the things that, the data scientists do, or the data analysts do. So now, if I had to kind of, conclude here a bit on the outliers, we could say that, and just something, why do they matter? There's an excellent example here, right? If you take the daily returns from the Dow from 1900 to 2008, and you subtract, just remove the 10 best days, you end up with about 60% less money than if you would have stayed invested the entire time. Wow. Just think about it. If you would have taken this data and if you would have removed the 10 best days, it just gives you 60% less money. Same thing, if you remove the 10 worst stock market days, you would have ended up with 3 times more money than you would have invested. That's how powerful sometimes these outliers are. They can change, they can make such a great impact, right? Or they could be your anomalies that you really care for because you're in cybersecurity. Your data set is about cybersecurity data set, which means that you have to dig out all those anomalies and find out if your applications, your systems are safe. So in the end, I would say that, sometimes you do need to keep this data or these outliers, and sometimes you don't need to keep them. But it depends on domain knowledge and problem in hand. And that's what will dictate the need, right? The problem on hand, like whether you really, it matters. I mean, it doesn't matter. It's up to you to decide. And once again, if you have enough domain knowledge to make that decision, that's very important, right? I know we kind of we'll work with many different data sets. So it doesn't mean you have to go and research and be part of each of them, but it's important. Like once you go into and do this, as part of your work, right? In future, you would have to know your domain area very well before you decide whether you need some data, or you can remove some data, or how you can enhance your data. It's very important. Okay. So now let's come to our discussion. Okay. So hope this, I get some theory done here. So I hope, we can get into some lively discussion here. So what I'm going to do is, again, I'm going to bring you all to this one particular statement, or this couple of statements in your discussion, right? In your discussion problem statement. It said very clearly, your leadership wants to know the average age of the customers and subscribers that are using the bike share program. So that's number one. That's what they're trying to do. This is your problem statement, by the way. They would also like to know the distribution of bike share users by gender. That's all they want to know. That's what this problem is about, right? And yes, we found outliers where there was a spike during the year 1969, or for the birth year, sorry, 1969. There was an inclusion of gender 0 in the data set. And we came up with multiple reasons, right? We all came up, as I would have also, we thought about default birth year, there being a default field, become loading of data from other systems, you had a coincidence of faulty data entry, came up with fake IDs and so on. And there are multiple reasons, right? We came up with many, many more than what I have mentioned here. But the point is that we all thought, hey, this is the reason. And we went into a lot of research and all that, right? So, but if you do a simple analysis, right? What is really important for the problem on hand, right? What are we really looking for? Do we really need the identification, or do we really need the age for for our users or about our users. We talked about gender zero. Hey, it's an unknown gender. So why do we need that? But let me question you all. Let's all brainstorm, or I would want you all to think about, why is gender zero incorrect? Right? In today's world, when you're talking about gender diversity and inclusion, well, you need to have a third gender option, right? When even nationally, like if you see last year, I don't know if anyone saw this news, nationally, the US also came up with the third gender option on their passports. So why is gender zero a throwaway gender in the data set? I would not, because I don't know what could be the reason behind that gender zero there. Right? Make sense, guys? Do you guys all agree? Yes? No?
Yes.
Okay. Yeah, thank you. So once again, going into our data set, right? Now, right, we want to look into our age. What is the age? So what I did was I said, okay, we want an average age by user type. So let me see what is all the different ages of user types. And as you can see here, the leftmost visual is maybe it's just a kind of an histogram here, which is the count of user type by age and age and user type. So this is all, these are the different ages. Now you'd say, okay, where was the age in this data set? Well, I just created a custom column. I said, okay, I'll create a custom column. And I had a birth year given, which was a numerical field. And I just did the math, 2020 minus the birth year that was there in the data set, that gives me the age. So I created a new custom column and I just did some analysis here. And you all saw this spike here, right? You had your birth year, you had multiple different ways that you put it on the x-axis, you had multiple different things you put on x-axis, but we all saw this similar chart. This visual should not surprise many of you here. But it's just kind of showing you that, just a count now. I've not gone to the actual problem solving, just wanted to visualize the data in the form of age. Like if I see the age and of my customers, of my subscribers, and if you want to take the both of them, you would kind of see them both together. What's the total? I can see the total. If I want to see an individual number, I can use this histogram where the light ones, like as you can see, 68,000 here were my customers. I'm sorry, the the customers, and then there was the subscribers. So I can get this kind of a view, right? I mean, that should not be a difficult thing. Then maybe I can make some decisions here and say, okay, I would like to just look at all the ages greater than 0 and all the ages less than equal to 75. The rest is probably noise in my data. Once again, this can be changed, right? I mean, there's no hard and fast rule. I'm not coming up like this is not like one solution here that is the right solution. I'm just showing you different ways this could be analyzed and kind of thought about. Now, if I do it this way, right, then I'm not taking it by user type. I'm just doing it and throwing in all the users in this data here. Then certainly if you look at the average age that I get for everybody greater than 0 and less than equal to 75, if I keep this data set, I get the average age to be 39.9. Okay, fine. But this is for all users, right? Our problem, if you look at our problem is average age of the customers and subscribers. Okay, fine. So let's do it for now. You can also, like before we get to doing it for the different user types, let us see what happens to this average when I take off the outlier, which in this case, the outlier was age 51, born in 1969, right? The birth year. If you see, the average age came down to 38.4, and initially it was 39.9 with the outliers. When I removed the outliers, the so-called outliers, it came down to 38.4. Now, is this 1.5 years difference a big difference for the problem on hand? Now, once again, it depends on why you're trying to find out the average age. If I just want to know, hey, are my users in their 30s or in their 40s or in their 50s, then this 1.5 years is not going to be a big difference that I should be really worried about, right? Anyway, let's continue to look at it from the from the different user type perspective, right? We'll say, okay, let's break it down. Let's look at what will be like if we keep the outliers. What is the average age? 39.6 years, and this is 40 years. Okay, fine. What if I remove the outliers? Then yes, my customer's age, average age goes down to 31.8, but my subscriber's age goes down just very little by 0.3 years. That becomes 39.7. So this way, I could see that, yes, it went from 39.6 years to 31.1.8 years, right, for my customers. And then the other one was probably, just this. So once again, by not removing the outliers, am I really getting, that huge difference that I should be worried about? Once again, depends on why was I trying to get the average of the users. If it is again finding out 30s or 40s or 50s, or just between 20 and 40, I would not even go any further. I would not waste my time. Once again, time is of essence, right? When you are at work and you're being challenged or given this problem on hand, then in every hour that you spend is a cost to the business. Now, would I kind of spend time now to, remove the outlier? Well, maybe not, right? Maybe I can still live with it. I don't know. I mean, I'll have to still find out why there was a spike. That's a different question, right? That I'll have to solve. Same thing for the gender. Now, there's another question was, distribution of gender. Now, many of you came up with histograms with 3 different genders. Well, that's so be it. That's the distribution. I would be okay to put gender 0 in my analysis, saying this is it. We don't know. We don't know. This is an unknown gender where people could have either not revealed their gender, or that's what the gender they want to use because that's fair, right? So once again, it's just kind of, sharing with you the thought process that, you should be all kind of going through, or, during your any kind of analysis that you go through. Okay. So now just before we go any further, but any questions, guys, any questions before we move on here?
I had one question.
Sure.
Something I was trying to figure out how to do on Power BI was like, if I wanted to say, figure out how many people are in a certain age group, like almost with the project where there's like the ages from I think the ages go from 18 to 60 or something like that. If I wanted to set it up to where I could do a graph to show how many, or like a circle, or even like a pie graph, how many people of this age are in this particular age group.
Yeah, you can certainly, you mean grouping of the ages that you wanted to do?
Yeah, because I tried to do it with bins, but I just couldn't quite get it right how I wanted it to be distributed.
Okay, Marco, if you could stay back after this, I mean, I can quickly show it to you, but there's one, I think there was one question in the online questions where they asked about grouping, how to group the different types of data. So let's see if we get time to kind of go through that, okay? Or if not during the session, then we can just, if you spend time, few minutes after the session ends, I could just quickly show it to you, okay? And the rest can also stay back. I'm just saying, I want to kind of go through the material and get, if everybody wants to leave at 9 or, within the next few minutes, that's fine. We can meet after that, okay? All right, so I want to get into this one here and just pose this question to you, right? So you are an analyst, and this is the World War II airplanes who are returning with bullet hits. So the data is you're seeing the airplanes and you're seeing where the bullets are being fired at and where it got the hits. So now the problem on hand is which area of the airplanes should be reinforced? What do you guys think? If you were the analyst, if you were the engineer, if you were the decision maker, which area of the airplanes would you reinforce, or the areas? What do you guys think?
I think I would try to reinforce. I guess my priority would probably be the cockpit.
The cockpit.
Yeah, I'd say the middle as well.
In the middle. Okay. So, okay. No, these are all good
And-
answers, by the way.
Yeah,
Cockpit,
and
middle.
I've actually seen this, but I won't give it away.
Okay, you've seen this. Okay. But
I've seen
this is okay. No, you give it away. Give it away. I would want you to kind of give it away. No worries.
So I think, yeah, this was like a meme or like a news article from maybe about 2-3 years ago. And the idea of it is that you should actually reinforce the places that are lit up in red. So like the wings, the tail, the back, because those are the parts that can actually take damage, because all the other parts that aren't able to take damage, like the cockpit and the others, those just will bring the plane down regardless. I think that, isn't that it? The
So
thinking?
okay, so here's the
Or do I
actual-
have it backwards?
You're close. You're close. But what you are seeing, what the engineers and the analysts were seeing are the planes that were returning back. What about the planes that were not returning back? That were hit, right?
Mhm.
Those planes were hit in the other areas. And that's why those planes never even survived. They never got back to the airbase. So what does that mean? That the planes that were hit in this area, in this area of the wings, or in this fuselage portion of the wings where there's fuel, these were the areas that need to be reinforced.
Okay, so it's the other way around. Okay.
Yeah.
Sorry about that. But
Okay,
it was
but you
like
were close, as I
saying
said, this was close. It was, and then this is like, I'll give you the source also. You can take a look at this at any time, but this is also called something called as selection bias or the survivorship bias, right? The bias is you're making a decision on what you're seeing, but you're not making a decision on, but you're not thinking about the data that you're not seeing. You're not seeing the planes that have not come back to the airbase. So sometimes this happens, like, and you have to also keep this in mind. So this is an excellent example where we could get biased, or we could just be completely blindsided to our data that we may not be seeing. Okay, so a good example there, and you can read about it if you interested. But I just kind of gave it away now as to where where were the planes really reinforced. Okay, so just to wrap this up, there are some quality dimensions that you want to assess for your data. See if it is accurate, complete, consistent, and time-bound. Is your information available whenever you need it? Validity, is it in the right format? Is it in a usable format? Is it unique? Is this the only instance where the information appears? Or, there are multiple data sets and your information is appearing in different ways. Like, you have a gender, male and female in one of your data set in one organization, the other organization carrying the same employee data or information, the gender is 0, 1, 2, right? Or something. So I'm just saying that sometimes you have to find out what's the duplication or what's the uniqueness, or where the data would be most unique. So all these things that all these different dimensions that need to be assessed, which happens in your data preparation phase. And there are things that will activities that would happen in your data preparation phase. We talked about data cleaning, right? What about the missing values? What about the outliers? What will you do with the noise? would you just take out the noise, right? All the ones that are really, really so many outliers. I cannot have somebody born in 1885. Okay, I cannot have somebody's age -1. I cannot have somebody's age greater than 75. That's like your data cleaning portion, right? You would probably be bringing in data from multiple sources. That could be the problem on hand would be dictating that. So you could be doing some integration. And sometimes some of these activities kind of need to be repeated, right? Maybe you do the data cleaning, you do some data integration, you go back to data cleaning, right? That may happen sometimes. You would have to transform your data. You have to sometimes reduce your data, right? Not just reducing the data, meaning the data rows, but maybe you're reducing the number of columns, right? That it has. Maybe certain columns really doesn't make sense to you. You don't want to know the address of your subscribers, maybe. Maybe that's all noise for you. Maybe all you need to know is, just their name, their age, and maybe their ID, whatever the ID that you want to give. I'm just saying that there are times when you don't need all the data that you may be capturing, right? Or you may have received. Okay, so anyway, so I know we kind of running out of time very soon here, and I want to talk and spend a few minutes on assignment 2, talking about that. But before that, any questions, guys? Any questions on what we just discussed? Okay, moving on, assignment 2. So I'm sure that a few folks already started, and I just wanted to kind of mention to you this assignment 2. Really, really want to get started as soon as possible. If you have not, you may want to do that today if you can, right? Because I'm telling you, there are things in here that is going to make you work in Power BI. That's going to make you, add, or take some notes while you're working on it. And it's going to ask you to also prepare a memo where you'll need some of your writing skills to come into play. So all that is kind of happening in assignment 2. So please do not take it lightly. This is not an assignment that you'll be able to do it in the last day or the last hour. So please do not wait for that. Do not wait for Tuesday, okay, when it is due. And most importantly, there is one thing more interesting coming up. Like halfway through your assignment, you will see that you will have to actually take a quiz, because in order to get through the second half of your assignment, where you have to resolve certain anomalies, you have to take a quiz, and you'll get 10 questions on that quiz, which is going to be on the steps that you would have taken, until that point in assignment, right? And with the data set on hand, it is going to ask you 10 questions, and you have to reply those 10 questions. If you answer all 10 questions correctly the first time, bingo, you'll get an email with the answers about those, or how to resolve those anomalies. If you do not answer it the first time, it is going to say, hey, you're pretty close, go for it, go for the second attempt. And you go for the second attempt, you get it all right, you get a congratulatory email with all the answers again. And if not, it will say, okay, we'll still still give the answers to you. So take the quiz. If you do not, if you're not successful the first time, do it the second time. If you're successful or not, you will still get the answers that you need, or the information that you need to continue with your assignment. This quiz is not graded. It is just added to make this a little more interesting as to how it will all play out in real world. Okay. Any questions here? Any questions about the assignment? Most important thing, please submit both the files together. There's a professional memo that is required, and that is a document that is required after you fill out the document on data exploration preparation, and that when you download it, you fill it out and you submit it along with your professional memo. Both the files submitted at the same time. Do not think, let me just submit memo first and then I will submit my other one first. Your assignment folder could get locked, okay? So please submit them together. And lastly, look at this rubric. If you haven't looked at, just go over, if the rubric is given to you, it's part of that document, read through it, because it's very important that you understand that what's kind of expected from you, and just look at how each of these things are that are expected, what is the different criteria, and what's the points given for each of the criteria. Okay, so if no further questions on the assignment, I've got these two questions. How you demonstrate how to group categories in Power BI. I'm going to quickly show that to you guys. I have to just, take this, I'm going to just unshare this deck and share my screen to go over the Power BI information. We talked about the other question, which is about, who created, what created the pick. I mean, we talked about the outliers, guys. Okay, so I think we talked about how to deal with it, which is also, once again, depending on the problem on hand, but we just kind of did some brainstorming and analysis on it. So I think this is the only one that's remaining. But before I kind of do that, any questions you guys have? Any impromptu questions? Let me see. I see some of the chat room. Okay. Excellent Salesforce question. I did not.
Yeah, I
get
don't
any
understand
tickets.
why. Yes, this is a
Yeah.
typical thing. Why nobody submitted a ticket? Why wait for the whole week to get this?
We could barely hear you, Yelena. I'm sorry.
Okay, I was saying, why wait for the whole week to get this question answered? Why not to submit Salesforce ticket?
Oh, okay, okay. So
They could nobody submitted the ticket, so I made an
I think this
assumption.
was more of a general question than
Oh,
anybody
okay.
who's kind of
Okay.
stumbled on. This is not
Okay.
part of the assignment, but just a general
Oh, okay.
question. Okay,
Okay.
already.
Because
So,
uh-huh.
so before I go on to and share this deck, I'm just going to kind of just quickly summarize. We talked about data preparation. We talked about the outliers, how to identify them, some possible ways to fix them. We talked about how sometimes we need, sometimes we don't need them. We talked about a discussion. We talked about in a very interesting problem about the airplanes and certain the dimensions that you want to check for your data. And we talked about assignment too. So for unshare, once again, before I unshare my screen, this deck, and go back to sharing my screen, you may ask any questions that you may have. Okay, so no questions. I'm going to share my screen. Just give me a second, please. Okay. All right, so let me, go back here. Oh, it looks like it shut down. Okay, no worries. This is by the way, this is the labs. If I know there are a couple of you are kind of using the virtual labs, so you may be familiar with what I'm trying to do here. I'm trying to open up the Power BI. It may take just a few seconds here. And I know we kind of running over a bit, so we are just about the top of the hour. If folks have to leave, and I completely understand, but if you can just wait for a few minutes, we will probably would need another 5 to 10 minutes max. I just wanted to show you about the grouping, which isn't like it's not complex at all. I'm just waiting for my Power BI to come up. Unfortunately, it just timed out while we were just going through our our presentation or this session. Okay, it came up well, and it came up with, okay, I'll have to open my, okay, my Power BI report. So this is the report I kind of used. So you saw some of the visuals that I came up with actually came from this particular one. Now I wanted to show you about the groups here. So, I'm going to take this away. Let me just, so the way you can group this is, let's say you want to group all the station IDs, right? Let's say I'll take end station name, right? I come up with the end station name and let this come up. So I clicked on this field and I would say new group. So you see here, I'm on the field and I clicked on those, that ellipsis, the 3 dots next to the field that comes up. It comes up with this menu here. I click on new group and it will open up here. Now, as you can see here, it shows me all these different groups. Like, let's say I want to group everything that's on First Ave. I will say, Avenue 1, right? So maybe this Avenue 1, anything Avenue 1. Oh, I went too fast. Okay, so this is my 1F, okay? This is my 1F data. So what did I do here? I just clicked on, let's say we'll do the 10th together, okay? So I clicked on 10th Avenue here. I'll call this 10th Street, or this is different avenue here. So let's call 11th Avenue. And these 3 records are for the 11th Avenue, right? So I want to group these 3 into, and so I click on group, and what it will do is create a group here. I can just name this group as 11th Ave, and I say, okay. Okay, so I just click out and it will be grouped now. So now I got 2 different groups here. So I've got 1 Ave, I've got the 11th Ave. Let's say I'll include all the rest in the other group. So what I'll do here is I can just, and just for the sake of, in the interest of time, I'm just going to group all these together into my other group. Oh. Okay, sorry. Okay, this should have been. Okay. So all this other contains the other groups. I don't have to do that. So I can just leave it here. Let's say I bring this. Now what it has created another field called end station name groups. Now, if I want a visual here, I could just bring a visual and I would say, okay, give me a pie chart. And I will just create this pie chart and I'll put the values here. You see here, it has created, and once again, I've not gone on to create all the different groupings there. There were multiple groups. I just showed you something very quick. I can just exclude my other group to show only 2 groups here, which is 1 Ave and 11 Ave. So this way I can just see my different groups here, and I can just change the charts here, right? I could make this as a histogram, or I can make it as a bar chart, whatever I would want. I can keep changing the visual here. But the main thing is that I've now grouped the certain data. My station names on 1 Ave, I've all grouped them together as 1 Ave. Same thing I did for 11 Ave, and so on. Okay, so now this is for when you have a category. The same thing would apply for the birth year. Let's say you want to do and create the bins for the birth year. So you would still have the same way to create it. Like you would create the birth year, you would create the bin, you would have the size of the bin. So it will start from 1885 to max value of 2004. And you can have the different bin size. You could have 50 bins, or you could have, the bin size could be 50, or it could be even more. Maybe you want to have it like 5,000. And you could create a different bins here. So you can just create a different birth year bin. Okay. So this way, you can create, if it is a numeric field, it will create different bins where you can group the data. And if it is a category field, it will create this, it will form the list. It will let you build that list for you. Okay. Does this help?
Yeah, that does help.
Okay.
It helps me too. Thank you.
Thank you. Any questions, guys? Any other questions before we call it a wrap? Somebody saying something. I'm sorry, Yelena. Is that you? I couldn't hear.
Oh, no, that's me. I was saying that at the very top, there is an icon called data groups.
Right.
That's what I usually use, but that's all right.
Okay.
More than one way to do.
Good, right, absolutely.
Yeah.
Okay. If no further questions, then we can all call it a wrap. The recording would be available soon and will be shared with you. I will share the presentation also. I hope you all enjoyed the session. You found it useful. And good luck with your assignment and the reading for week 4. Okay. Thank you. Good night and good day.